Okay, now in this lesson, what we are going to look at is the one-way analysis of variance, and I'm gonna refer it as ANOVA from now on, okay? Now, so in the previous chapter, you saw that we were doing two sample t-tests. So that's only happens when you have two groups and basically that you are comparing with. Now, very often there are times that there are more than two groups. In which you will have three or more groups where you have three or more levels depending on your setup, okay? And then so how do you analyze that? Well, it's basically something very similar to, I mean, you can do something like a multiple t-test, but then every time you do that, the false positive rate, or if you would like to see it as the type 1 error rate, is going to go up, right? So what you need to do is something called the one-way analysis of variance. And then if you have a significant result, and then you follow up with the multiple pairwise comparisons, a post hoc. Okay, now the post hoc should not be in the form of a multiple t-test unless you do something called the Bufferoni correction, which I'm sure you guys have talked about it in your lecture. And then now, so the post hoc that is most likely used is something called the two-key HSD. Okay, honestly significant differences. And so that's exactly what we're going to do in this lesson. Okay, so let's just go right into it. So the first one we're going to tackle is going to be the one-way ANOVA, but independent groups, one-way ANOVA. Okay, so which means that this is going to be three different groups and not three different levels in the same person, okay, but three different groups. Okay, so let's just go through the data set 8.1. Right. A developmental psychologist is wondering how toddlers learn. He is particularly interested in how young children learn the alphabet, ABCs. Okay, now with all the videos, computer programs, and so forth, he is interested in discovering the method by which the children learn quickest. To try to answer his question, he gathers a sample of 24 children who just turned 2 years old. These toddlers have not yet mastered the ABCs. He randomly assigns 8 children to one of 3 treatment groups. For the first group, the children's moms sing the ABC song with them once per day. The second group is exposed to a cute and fuzzy TV character singing the song, and then the third group learns the smartphone app. Okay. The psychologist measures how many days it takes before the children can correctly recite, I guess, all the ABCs on 3 consecutive days. The data appears on the next page. Okay, so it's over here. Okay, so let's conduct the one-way between groups ANOVA. Okay, let's see. So let's start with the SPSS, and then let's go to the variable view. Okay, now I'm just gonna scroll over this a little bit. Okay. Okay, now, so the first one you want over here is method. Okay, and down here is the days. Okay, and that's 0, the decimals. Let me see if there's anything else that you need to do. Okay. Okay, so next define the groups. Okay, so we need to go to value. So value 1 and the label that will be mom. Okay. And value 2, that would be the TV character. I'm just gonna write TV underscore character. Okay. And then 3 is going to APP, okay, computer app, right? Now, when we're done, click OK. All right, now we can go to the data view. Okay, now the data view, the way that you want to organize this is not mom here, TV here, TV characters here, and smartphone here. What you want to do is because has to do with the SPSS, the way that it's organized. For each row, the computer recognizes it as one person, the data from one person. Okay, so the way you need to organize this is going to, you need to tell the SPSS this person belongs to the mom group. All right, and now you can just copy this down, and that's it. Okay, and then the next group is going to be the to group. So that's a key TV character, right? So you can copy this down, and then that's it. Okay, and then the next one is the smartphone group, right? So it's gonna tell you APP. And then let's just copy this down, and that's it. Okay, and then we just need to type in the numbers here. 9, 10, 11. Okay, no, okay, and let's go down and okay. Now, so what do we do next? So now we need to go to, let me go down, okay. Now let's go to analyze, compare means, and one-way ANOVA. Analyze, compare means, one-way ANOVA. Oh, come on, one-way ANOVA. Okay, now it's gonna ask you that what is the dependent list? Well, so that is your dependent variable. So what is dependent on the method? Well, that's the number of days that they took them to learn the ABCs, right? So you put that in here. So what is the factor? So in other words, what is the thing that is altering or could alter the number of days that these babies with small children learn their ABCs? Well, that would be the methods, right? So over here, load this in, okay? All right, now what we need to do, we're not done yet. What we need to do is to pick the post hoc, okay? And then the one that we need to pick would be the Tukey, okay? Let's pick that. Now let me see what your textbooks still, oh, okay, no, your textbook wants the LSD. All right, so let's use the LSD. This is a very powerful post hoc, by the way, okay? And let's check to see the significance level. Okay, 0.05, that's good. All right, let's click continue. Now the next thing I think your textbook wants you to do is to look at the options, okay? Now, what kind of options they want us to do? All right, so descriptive over here and the homogeneity of variance test. Okay, now let's click continue and then click OK. All right, now so this is the actual output. Okay, let me just put this over here and then let me minimize this a little bit. Can I make this smaller? No, I can't. Okay. I can't zoom out. Okay, all right, I'm just gonna have to toggle back and forth. Okay, now let's take a look at the descriptive statistics. Okay, so this is the number of people that participate in the group, and that's the total, right? And over here, that is the numerical average. Okay, and the standard deviation, of course, and the standard error, the mean. Now, what else do we need? Oh, we don't really need anything else from here. I mean, the upper bound and the lower bound of the 95% confidence interval, it just kind of tells you where the error bars would be if you are using a 95% confidence interval for mean. But we're not. We're using the standard error of the mean. So that is kind of like a moot point anyway. Okay. Now let's take a look at the homogeneity of variance test. Okay, so the homogeneity variance of test, the thing that you need to, did I make a mistake in the actual data? Huh, I must copy this wrong. I knew it. Okay. So I think copy too fast. Okay. All right. Let me redo this again. Okay. So analyze, compare means one with ANOVA. Okay. So this is already in there. That's already in there. Okay. And options, that's already checked. So click OK. All right. Now let's go down. Now, do the numbers match? Okay, yes, yeah. Now the numbers match. Okay. Now the ANOVA. All right. So all the numbers match now. Okay. So the ANOVA, what it's gonna tell you? Oh, no, not ANOVA yet. Okay. So the test of homogeneity variance basically tells you that what is the distribution when it comes to the actual variance between the means. Okay. All right. And so basically, this is kind of tells you that should you even go on to do the ANOVA or not. Okay. So we can. Okay. So now the ANOVA results over here tells you several things. So the things that you really need to pay attention to is there is the numerator that is the between groups, and there's a denominator that's the within groups. Okay. And what you need to look for are several things. Now, one is the degree of freedom for the numerator, which is 2, and the degree of freedom for the denominator, which is 21. Okay, and the most important thing is the f value. Okay, so the f value is 15.92, and then the significance level is 0.000. Okay, now what the a significant ANOVA tell you here? Okay, so 0.000, which is a lot less than 0.05, right? And then so what you're basically looking at is something, oh, there is a significant pair that is different from one another within this analysis of the variance set. Okay, so which means that so that means that there is at least one group that is different from another group. Now, if all three groups are exactly the same, this number would be greater than 0.05. Okay, so in other words, if there is no significant effect of the methods on the number of days learning the ABC, then this number would be greater than 0.05. Okay, but now it's less than 0.05. That means that we reject the null hypothesis. Okay, now since we reject the null hypothesis, what that means is that there should be a significant effect of the methods on the number of days that these toddlers learn the ABCs. So, what do we need to do next? Well, we need to do the post hoc test in order to find out which pair is different from one another. So, so the post hoc test, what it does is it compares all the possible pairwise combinations. So you got mom against the TV character. That's one possible combination, right? And you got mom against the smartphone app. That's another combination, right? And then you got TV characters against the smartphone app, right? So this is why. So now the multiple comparisons for the post hoc, what they're doing here for LSD is that it does this for every possible combination, regardless of order. Okay. Now the order of that is it doesn't really matter because when you are looking at the order of that, you should really kind of take the to take the absolute value anyway. So, but you see that because the way that the comparison is done, this is using the mom against, for instance, a mom. This is the mom against the TV character, and you got a negative a negative 0.375. Now, when you look at the other way around, when you look at the TV, minus the mom, then essentially what you're looking at is a positive 0.375. Okay, so that's what the differences mean. So this is taking the I over here, and minus the J over here, and that's how it derives the mean difference. Okay, and now they give you the standard error, and then they also give you the significance. So now the things that you need to pay attention to is really these two things, the mean differences and the significance. Okay, so the significance is the p-value for the pairwise comparison. And then the significance of that really is kind of telling you that is there any differences between mom and the TV characters? And then so the significance of that is 0.76. So this is a lot bigger than 0.05. Okay, so no, so there is no significant difference between the mom and a TV character when it comes to the methods. Okay, now what about the mom versus the smartphone app? Okay, so what we see is that this is a very small number, 0.000, right? So it's a lot less than 0.05. So what we're looking at is that there is a significant difference. Okay, now so we're done with that. Now let's take a look at the TV character against the app. Okay, so TV character against the app, and what we see that the significance is yet again a very small number. So that means that the TV character method versus the app method is also different. Okay, now it's time for you to kind of make a ruling of that, and then just kind of get an idea what is less and what is more. So, and that's how you would derive your interpretation of the data. Okay, now, okay, so now we're all pretty much done with all of this. Now, let me see if there's anything else that we need to, okay. All right, so it's pretty much done here. All right, so let's take a look to see what happens when you are interpreting between the groups. Okay, so if it's significant, then analysis shows a significant effect of the independent variable name on the dependent variable, and then you report the statistics. And the statistic is basically here. Okay, so you put in F parentheses. Okay, so F parentheses and degree freedom of the between groups, and then comma the degree freedom of the within groups. So what you need to put in here would be F parentheses 2 comma 21 close parentheses equals the actual number of the F value, and that would be 15.92. Okay, and then followed by another comma, and then P is less than 0.05. Okay, then after that, then you compare the means. Okay, so and that's so basically here. Okay, so then when you compare the means, then you say that the post hoc testing revealed that the mean measuring, so let's say mom against TV character, right, is a higher, or is it lower? Okay, so it's not significantly different, right? So you can say that between mom and TV character, the result is there is no significant difference between them in the how many days that the toddlers took to completely recite the ABC, right? And then you put in the then you put in the p-value. Okay, now then you basically do that for all possible comparison. Okay. Okay, now here what they're doing is basically showing you what I just told you. Okay, so you can see that the analysis revealed a significant effect of teaching method on mean number of days needed for the children to learn their ABCs. And then you see that they put in the numerator, a comma, followed by the denominator, and then close parentheses equals, this is the F value that's obtained, and then followed by another comma, P is less than 0.001, 1. Okay, so now the convention is usually that you can just put in like p is less than 0.05 and that would be fine. Okay. Now post hoc testing revealed that it took significantly longer for the group of children who learned by the app, and then you see, okay, so this number, the n of 16 is up here. Where? Okay, here, right? So the mean of 16 goes to goes where we were looking at, okay, over here. Then those who learned by their mom singing, okay, and then guys, and then you can see that the mom sing is 9.88, and that's 9.88, right? And then or the TV character, right? So and then you can see that they also reported that the 10.25 over here for the TV character as well. Okay, now even though it took slightly less time for the children who learned from their moms than the group who learned from their character the difference was not significant because we saw that down here that this result is really not significant. We compare the TV with the mom. Okay. Okay, the findings suggest the children's mother and familiar are better at teaching ABCs to young children than the smartphone app. Okay. Now, are we done yet? Well, we're not done yet. We need to actually graph out the data. Okay, so how do we do that? Well, let's open the Excel. And so what you need to do is organize it like this. Okay, so got mean here, got SEM here, you got mom here. I'm gonna say TV character. Okay, and then this is the app, right? The app. So just kind of copy these numbers over, and you're probably asking, well, where did you get those numbers? Well, we got those number from the data here, the descriptive data, right? So it tells you what the moms mean and TV character means and app means are. And then it also got the standard error over here. So all you need to do is just kind of just copy that over, okay? 16, okay. 0 and 1.15. Okay, now we don't need the textbook anymore. I'm just gonna do it from here and show you. Okay, now you highlight this and then go to insert and then go to the bar 2D column. Okay, now the first thing you want to do is just get rid of the actual delete, get rid of the grid lines. Okay, and then let's go to here and format the axis, and then let's go to the line and then change this to black, and let's do exactly the same for the x-axis. Okay, and now let's change this to, all right, so that's 14 already, that's good. So let's change this to 14, change this to 14. Okay, now so you want to say something like the effect of the independent variable, which is the teaching method, the dependent variable. So on number of days toddler learn ABC, something like that. Okay. All right. Now, what else do we need to do? Well, we need to give the axis title. Okay. So go to chart design and then go to add elements and add the horizontal axis title and then add the vertical axis title. Okay. So down here, you want to type in something like teaching method. Just gonna make this bigger 15, so we're good. And then now this would be the number of days toddlers learn ABCs. Well, you can say alphabet. I have 14. Okay, so that looks pretty good. And then let's also add the tip marks over here. So go down here, tip marks, major type. I'm gonna use the inside today. Okay, now what else do we need? We need the error bars. That's what we copied down the SEM for. So go to this. So what you need to do is first highlight this, okay, and then go to add the sign over here, go to error bars, and then click on this arrow, and then go to more options, and then go down and go to custom, specify value, and then click on this, highlight that, click on this, and then do this for the negative value again. And click OK, and voila, we're done. And then now the error bar is kind of hard to see because of the color. So what you can do is you can change the fill, okay, and now the outline doesn't look very good, so I'm just gonna change that. So that's it. Okay, let's see if it looks pretty much the same as your textbook. Yep, you know, yeah. Yeah, I mean, I don't really like this title. I think your title should really be the effect of the independent variable on the dependent variable, okay? And because when you get to this, when you get to the experimental psychology, that's what your professor, it might be me, that requires you to do this in experimental psychology. So it's a good method. It's a good habit to really learn that and from now on. Okay. Now for the next part, we're going to do the data set 8.2. So in data set 8.1, what we did was doing a between groups ANOVA design, where you can say the independent groups one-way ANOVA. Okay, now in data set 8.2, what we're dealing with is a repeated measures ANOVA. Okay, so that is going to be the within groups design. Okay, so now let's read this over and see what we can do with it. Okay, now remember the example in the previous chapter with the sports psychologist who came in to help the local college team with their free throw completion rate. Well, apparently the word got out, and one of their rival team is having the same problem. The coach calls the psychologist and asked if she would be willing to work with his team. Ethics specifies that successful intervention should be made available when possible, so she agrees to help his team with their shooting starting at the beginning of training for the upcoming season. Since she has a whole basketball season to work with these players, she would like to further test her video and feedback intervention by running more sessions, and then eventually stopping the program to see if the intervention has lasting effects. She works with 10 players on the new team and measures them at 4 time points during the intervention. Before the intervention, after 5 sessions, after 10 sessions, and finally a week after discontinuing training. The data appear below. The measure below represents successful free throws out of 30 attempts. Okay, so here what we see is that you got player A, and then so in 4 different time points, basically. Okay, so I'm just gonna tell you for the example of the player A, and then you can just kind of apply for that for the rest. So in player A, before the video intervention, he out of 30 attempts, he was only making 8 free throw. And after 5 sessions, he improved to a 10. And after 10 sessions, he improved to 12. And after and then now after 1 week after discontinuing training, he is performing at 13 free throws. Okay, and so forth for these one. And then you can see that there should be 10 people here, and then we do. But you see that each person has 4 data points. So in other words, we got 40 data points over here. Okay, now that go back to our friend SPSS and go to the variable view again. Now the variable view this time, when you set this up, is going to look quite different. Because remember that we said that in the data view, it's going to recognize this as one person, right? So in the variable view, what you need to set up is going to be set up as if each one its own it's own, how to say this, it each column as its row condition. Okay, so over here you got before, and the next one is going to be after 5, and then after that is going to be after 10, and then this one is after they got discontinued. Okay, the decimal should all be 0 0 0 0. Now if there's anything else, data view. Okay, so we are good. Let's go back to the data view. Okay, and now let's just put in all the numbers. Okay, I'm gonna go back to this because this is slightly bigger for my eyes. Okay, and just make sure that you put in the right numbers. Don't make the same mistake that I made the last time. Because when you copy this wrong and then your data are going to your output data is going to look like completely different, and then that's not good. Then you're wondering what is wrong because you copied it wrong. Then of course all your data are wrong as well. Okay, I'm just gonna check the numbers to make sure that I did everything correctly. Okay, I think I copied everything correct. Okay, now let's go down. Okay, to analyze generally a general linear model and go to repeated measures. Okay, now it's going to ask you how many levels. We have 4 levels here, right? Because we got before, after 5, after 10, and discontinued. Right, so we got 4 levels. Okay, now what does it want you to do? So you put in add here, and oh wait, let me remove this. Okay, so because we need to actually type in session here, so we have a good idea which session we're looking at. Okay, so it gets loaded here now. Now let's just go down and let's go to define, and it's gonna ask you what is the 1 2 3 4. So all you need to do is just basically highlight all of these and then just load them in here. Okay, now what else do we need to do? Okay, once the session name has been removed over, click EM means. Okay, so display means for all of them, basically compare main effects, And then the one that you want to use, I'm not so sure what your textbook wants. Okay, it wants LSD as well. Okay, all right, so let's use LSD. Click continue. Now, what else do we do? We need to go to options and then click all of these things here. Descriptive statistic, estimated effect size, and then the observed power. Then click continue. I think we're good. Okay, so let's click OK. So these are the within subjects factor effects. Okay, now I'm just gonna get rid of this so we can see it a little bit uh, clearly. Okay, so you can see that the numbers, all right, so we did it right. Okay, so the descriptive statistics and then before, after. So it tells you the mean and the standard deviation and the number of people. Okay, now the next thing what you need to do is to look at, so don't worry about the multivariate, don't worry about the test of specificity. So you just need to go down to this thing, the test of within subjects effects. Okay, so the test of within subject effect is basically telling you a few things. So remember that in the beginning, very similar to your um, your previous data set problem, you are also going to get a degree of freedom for the numerator and a degree of freedom for the denominator. So the degree of freedom of the numerator is going to be 3 here, and then the degree of freedom for the denominator is going to be 27. Okay. Now the f value is gonna that you obtain is going to be this number. Okay, 24.886, and then the significance here, that this is the p-value. Okay, so it's 0.0. So what do we have? Do we have another significant effect or not? Yes, we do. Okay, so this is a highly significant effect. Once again, very similar to your 8.1. Excuse me. Okay, now the next thing what we need to do is you don't need to worry about all these. All right, so what you need to really need to really look at is this number. Okay, so this is the estimated margin means. So it tells you that, all right, so I just want to say that what does a session 1, 2, 3, 4 really mean? Now, if they tell you up here, sessions 1, 2, 3, 4, 1 is before, 2 is after 5 sessions, 3 is after 10 sessions, and 4 is at discontinued. Okay, so this is basically telling you, yeah, that's basically telling you down here. Uh, so this is before versus after 5 sessions, before, after. Come on. Okay, so this is before with after 5 sessions. This is before after 2 sessions, after 10 sessions, and this is before versus discontinue. Okay, and then so you'll see that your textbook is basically circling out all the ones that you need to do, because you see that just as before there are duplicates of data. And that's because the direction does matter when it comes to this. Um, so you see that, so these are all the significance values that you need to report in your basically in your interpretation of the data. Okay. Now let's take a look at how you would report this. Well, the way that you want to report it is very similar to the independence test, ANOVA. And so the way, well, your textbook here tells you like a very good way of uh, describing it. So, and everything is pretty much exactly the same as data 8.1. So I'm not going to go over it that much. We'll just see what they wrote here. Okay. So the analysis revealed a significant effect of the video feedback intervention across sessions on mean free throws completed. Okay, so the F value, open parentheses 3. That's the the numerator, comma, 27, that's the denominator. Okay, degree of freedom for the denominator, close parentheses, equals 24.89. So that's the F value that we obtained, right? And then P is less than 0.01. And then the post hoc testing revealed that the completion rate was successfully was significantly lower before the intervention than after 5 training sessions. Okay, so basically it kind of tells you that the mean completion rate is would increase as the training session progressed, and once that the high and what's the ones was actually highest once the intervention has stopped. Okay, so basically it kind of tells you that the video feedback intervention is effective at increasing the free throw of the completion rate and appears to have lasting effect basically. Okay, now, so we're not done yet. We still have not graphed it out. Okay, so let's just graph this out and let me do that. All right, so let's open the Excel. Then just gonna copy this over. So we got mean and SEM. So we got before, after 5, after 10, and discontinue. Okay, and then just copy over the numbers, 17.3, 7.4, okay, and 1.37. So these are exactly the same as the way that you got them from the SPSS. Okay, so I'm not going to go over them again. If you have questions, look at your problem set 8.1 of how we got these numbers. Okay, now let's highlight this. Okay, and after you highlight them, hit insert, and then go to this. And click on this. Okay, now okay, so let's get rid of the grid lines and let's write the title first. Okay, so effect of video intervention on the number of free throws. Okay, now let's change this to outline that. That looks good. This, do the same, exactly the same thing. Okay, now let's make a chart design, add chart element. Let's add in the axis titles. Okay. Okay, the axis title, this should be what? This should be something like sessions, or something like the type of sessions, right? Type of sessions, something like that. Okay, so now the axis title here would be number of free throws. Okay, so I'm just gonna change this to 14. I mean, if on your exam you don't really need to do this. This is just my pet peeve. I like to make the graph look pretty, and then okay. Now on your exam you should have like the content that is all there. Okay. Now the content is the more important, but just make sure that the numbers are not super small that I cannot see it, because if I cannot see it, I cannot give you credit. Okay. So tick marks. Let's have this in. Let's do outside today for this problem set. I mean, now let's make this look slightly different than before. So I don't know. Let's maybe use yellow. Okay. The outline. Let's use this. Okay, we're not done yet. Okay, because we need to add in the error bar. Okay, so highlight these and then go to this and then go to error bars, click on this, more options, and Okay, scroll down to customs, specify value, go to this, highlight this, do this, and then highlight this again. Okay, and then click OK. All right, voila, that is basically your graph that you need to do for this. Does it look pretty much exactly the same except the color scheme? Yep. Okay. Yeah, but the title, you really should have it as effect of something on something. Okay, so effect of the independent variable on the dependent variable. Okay, so number of free throws, the mean number of free throws. Yeah, that's fine. Yeah. Okay, so that's it for this lesson.